This is the second video of our first day. In this video, I'm going to address the question of what is physics. I could give you a typical dictionary definition, but I thought it would be more interesting to go over an example. Here I'm showing two cylindrical objects, a ring and a solid disk. These objects share a few traits in common. The first is that they have the same diameter, so they were manufactured especially for our purposes today. The second characteristic is they have the same, or roughly the same mass. So you may wonder, how can an open ring have the same mass, or you could say the same weight as a solid disk? Well, the ring is made of metal and the disk is made of wood, so the high density of the metal compensates for the lower volume. Here's just another picture so you can see the similarities. Alright, so what we're going to do with these two cylinders is we're going to race them down a ramp. I'll remove the wooden block and we'll just let them roll down at their own pace. What I'd like you to do is think about the properties of the disks and decide which object will win the race. Okay, before you commit too much to one of the objects, just remember they have the same mass and the same diameter. Think about that and see if it changes your decision. Okay, now I want you to go ahead and make a firm commitment. We've got three choices. Either the ring's going to win, the solid disk, or of course it could be a tie. So pick one of those and commit to it right now. Okay, the best way to test this out is just to let them roll, and so we're going to watch and see what happens. Okay, so we had a clear winner. It was the solid disk. Physics is a science, and an important issue in science is the question of reproducibility. So before we can be confident that the solid disk is going to win every time, we need to test if this is a reproducible result. The best way to do that is just simply repeat the experiment. Each time we're going to call it a trial. So the more trials we get, the more data we collect. More data will allow us to make some statement as to the significance of our result. Alright, now we have three data points that state the solid disk is the winner every time. 3 data points isn't necessarily good statistics, but it's better than 1. Another issue we should address as good scientists is the possibility for other explanations. We could spend a while doing this, but we're just going to focus on one. And I think this one's pretty obvious. What if it was just the starting position? What if there was something about that far position for the solid disk that gave it an advantage over the closer position for the ring? So to test that, we're just going to do more trials, collect more data. Watch this time, I'm going to swap their starting position. Okay, so now we have 5 separate data points, and we've considered at least one other factor that could have been influencing the results, and all of those has shown us the solid disk is the winner each time. Here's where physics comes in. Why did the solid disk actually win? The fact that they had the same mass and the same diameter made it so both cylinders experienced the same force and torque. If you don't know much about force and torque, don't worry, we're going to talk a lot about those this semester, so you'll be familiar with those by the end. When I look at this observation, it actually makes me think that there should have been a tie. If they had the same force and the same torque, wouldn't they roll down in the same way, and so they would tie at the bottom? Well, the missing piece to this question is a concept known as rotational inertia. The solid disk had less rotational inertia than the ring. If you're not familiar with the concept of rotational inertia, don't worry about it. We'll discuss it later in the semester. Here's a preview. Rotational inertia is a measure of an object's resistance to change in rotation. So maybe I could say it another way. Since the solid disk has less rotational inertia, it's easier to rotate the solid disk. There's less resistance to that change in rotation. So if both cylinders are experiencing the same force, the one that's easier to change rotation will start to rotate faster, and that's what's happening as they race down the hill. They're changing their rotation or speeding up, so the solid disk is the winner. You could make a comparison with the concept of inertia, not rotational inertia, just inertia. Inertia is a measure of an object's resistance to change in motion. It's connected to the idea of acceleration. So if you take a small rock that has small inertia and you apply a small force, you can still actually change the motion of the rock fairly easily. But if you take that same small force and apply it to a large rock, which has large inertia, you'll get much less effect or much less change on its motion. So rotational inertia is really the same thing. It just applies to the rotation rather than the motion. Now, if we had this knowledge before we started our experiment, then we could have easily predicted the winner of the race. So this is an example of why physics is useful, and hopefully give you an idea of how we're going to use it. We still haven't exactly addressed this question. What is physics? I decided not to go with a dictionary definition here. You can go ahead and look it up. It'll say things about matter and energy and all that stuff. But to me, this is how I like to think of it. Physics is simply the science of how things work. I love knowing how things work, so I get really passionate about physics. I'm hoping I can spread some of that interest and some of that passion to you guys during this semester. That's all I have for this video. In our next video, we'll be starting the actual coursework for the semester. We'll be covering material from Chapter 1 in our textbook.